In this video, I'm going to cover chapter 1, the introduction to statistics. So uh, let me cover that chapters using my lecture note. So this lecture note, you can download this lecture note in Blackboard. So go to the course material, then you see instructor lecture note, and then click the chapter 1. Then you can see you can see that the the note. Okay. So first one, there are two types of statistics we're going to learn in this course. The first one, descriptive statistic. Second one, inferential statistic. So descriptive statistic means the we're gonna the 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 summarize or analyze the data by using the drawing the graph or just the making a table so that people can easily figure out the the distribution of the data, or they're gonna decide certain things using the data. In the inference statistic, it means this: using the sample data to make inferences, which means a generalization or a conclusion about population. So here, population means the whole groups, and then the key point is in inference statistic. Key point is how we collect the sample data from the populations. So we're gonna talk about this one the later soon. But let's see example one. They estimate the percentage of Americans who are left-handed. So then the all Americans gonna be the group of all Americans gonna be populations. And then if you just collect the uh, s- the students in our school as a sample, then sample data gonna be all the students in this class, or the in this school. Or if you just collect the data from the just our class, then our class gonna be just sample data. So, but it's not fair, right? So when you just collect the data as a sample, we have to select Americans the equally in every single state or city, right? So we're gonna talk about this one later. The second one, do the left-handed students in this class fairly represent all left-handed Americans? No. Right, that is, yeah, is there any reason to think that the percentage of left-handed students in this class is different from the percentage of left-handed Americans? So the yeah, it's likely to be different um, from the percentage of left-handed Americans, because if you the survey the left-handed students in this class, then what, that doesn't represent all the Americans, because we didn't think about the age and the educations, and then also the location. Okay, now next one, a small sample is not necessarily a bad sample. So as long as we collect the data um, fairly, then the sample data could represent the population. So this one we're going to talk about this one later. The example two: estimate the percentage of college students who are Christian. So population going to be all college students. The sample going to be NGU students in this class. So now then the even even if we just collect the data from not just our class but just the school, in our school, the that sample doesn't represent the population fairly, because the our school is a Christian school, so most of the students, I believe most of the students are Christian. So that in this case, that sample going to be a bad sample. So so we get talk about, so in this case, yeah, so in the inference of statistics, um, the sampling is really important. Important. It turns out that sampling is really important. So let's talk about the what kind of bad sampling are there. So first one, self-interest study. So researcher receive funding from someone who will benefit from the research. Then this researcher will likely to the get research that's give that the what someone who will benefit from the research. So now the horses, you see example, horses funds a study to determine if chocolate prevent the heart attacks. So next one is voluntary response sample. So respondent themselves decide whether to be included. So people with a strong opinion are more likely to participate. So the for example is a voluntary course instructor survey. So the in when you just the survey about the course and the instructor who gonna respond, definitely just students who took the course. So that's not a good sample. And the next one is an online survey that asks if people eat a healthy diet and exercise. Who's gonna respond? The in the then what decision? The people who the what all the in this survey the people who use the internet very often can respond that. So, but we need to get the people survey who don't use the internet very often too. So it's not a good sample. And then next example, 1936 president's election. So literally digest sent a survey to uh, their subscribers who to people who own the cars or telephones. So got 2.3 million responses. The predict of Landon would win. And a large sample is not necessarily a good sample. So in this case, the result is what? They print London out the what? Alfred Landon would win. Didn't win, right? So what's the problem? Because that the digest just sent the survey to only the subscribers and then to people who own the car and telephone. So the they didn't get the survey from. They should have sent survey randomly, but only people only people to have own the car and telephone. So that's why the sample was not collected fairly. So next one, report this result. Better to take a measurement yourself, asking people what they weigh. So then the what they will likely to lie about their weight. And then next one is a loaded questions or order of question. So should the president have a line item better in the budget to eliminate waste? Or versus should the president have a line item veto in the budget? So the in the questions, the normally people look at the if survey questions are not worded carefully, the result of a study can be misleading. So survey questions can be loaded or intentionally worded to um, the elect desired response. So this is one of the example. So the actual rate of yes response for two different these two different wordings of questions. So first in the first questions, the 97% say yes, and for the second question, the only just 57 questions yes. So the when you the survey this question, they you have to separate two questions completely. Okay, and then now then next one next example, does traffic contribute more to air pollution than industry? versus those industry contribute more to air pollution than traffic. So similar to, yeah, this is a also um, the one example of loaded question, but that's the more related to order of questions. So sometimes survey questions are unintentionally loaded by such factors as the order of the items being considered. So see, look at the the two questions. That was a poll conducted in Germany, along with a very different response rate. So first questions, 45% blame the traffic and 27% blame the industry. For second case, the second question, does the industry contribute more to air pollution than traffic? Just switch it to items. They only 24% blame the traffic, and then 57% blame the industry. So in this case, I told you, how can you do? They have to, they had to completely separate the questions. The next example of bad sampling is non-response and missing data. So the non-response occurs when someone uh, they either refuse to respond to a survey questions or is unavailable. Okay? So people who refuse talk to the pollsters are likely to be different from those who do not refuse. So, for example, 2016 presidential elections. So most polls predicted Clinton would beat Trump. Then how do we get data from non-responders? So social networks, data mining on internet, Gmail, something like that. So the in the that poll, they couldn't collect the data from the non-responders. And then a second. Next one is the give me a second. I just missed the one more. Let's see one of the bad bad sample here. So give me a second. All right. So here the other and then one more the next one is the arithmetic errors with the personality and scientific notations. And sometimes they're confused with the personality and then the number, they're just number. Okay, for example, 2%, 6% of 1,200 is 72, but the 6% of 1,200, the sometimes they confuse the actual number, or they just made a mistake the figuring out the actual number of 6% of 1,200. Okay, and then 3/4 is 3 divided by 4, which is 0.75, and then which is 75%. And then the sometimes what they confuse with the 3/4 and the 75%. They think they're different, but actually they are same. They just equal, right? And then so normally they almost most of the error from the arithmetic error from the percentage. Okay, so keep in mind is the 6% means 0.06, and then 75% means 0.75, and 2.5% is 0.025. Okay, and then the other one is you see E10, that means the times 10 to the 10th power, and the E negative 3 means 10 to negative 3. Yeah, I just always mentioned, I said that I missed the one, the example of bad sampling. That was the misleading. You can find the misleading textbook. Missing data, I'm sorry, missing data. What's missing data? So when collecting sample data, it's quite common to find that some values are missing, ignoring missing. Okay, so ignoring missing data can sometimes create a misleading result. For example, it's just um, when you go to when you visit the hospital, and then or doctor's office, and then the you are asked to fill out the form. Okay, you fill out a form, and then the you know, the nurse can the enter the information into the micro Excel, I mean Excel or computers. But while just they just enter the all the data and put in the data into the digital sheet in the machine, a computer, maybe they made mistake. Okay, so the skip your age or skip your the height, something like this. Then it turns out that the data is misleading. So in the example of other example misleading is this: a survey question asked each respondent to enter his or her annual income, but respondent with a very low income skip this question because they find it embarrassing, something like this. So that causes missing data. Okay, and then now next one is type of data. Okay, so first one, parameters. What's a parameter? This is a numerical measurement describing some characteristic of a population. So then statistic means a numerical measurement describing some characteristic of a sample. Okay, so we use a sample statistic to make inferences about population parameters. So and then let's see. Let me go over quantitative data and then qualitative data, and then we'll see example. Okay. Uh, Quantitative data means numbers that count. Discrete, that means a number of siblings or a number of some items. Okay. Or measure continuous weight, height, or the the length, something like this. Okay. And the qualitative data is also called the categorical data, is a name or label that describe eye color, certain ID number, digital number, password number, okay, something like this, or um, level, low, medium, high, something like this. So it's an example, statistic or parameter. Let's see, let's figure out if this example represents statistic or parameters. So the average population of the 50 US state capital is 250,000 people. Okay, so is this statistic or parameter? It should be parameter, right? So 50 state US state capital. So average population okay, population of what? The 50 US state capital. So all the we've figured out the average population of all the state capitals, right? So it should be parameters. And then in a random sample of household, you see that in a random sample of household. So that means what? From the sample, we calculate 40%. We figured out 47% out of what? 47% of the random sample of household had a high definition TV. So this should be statistics. Okay. Now so keep in mind the parameter is what? So for the mean or average, we're gonna learn later, but standard deviation or the variance of population. Okay. The statistic is means the uh, the average or mean or standard deviation or variance of sample. Keep in mind this. Now, next one, um, discrete or continuous. We see the House of Representative has 435 members, so it's discrete, right? So we can be countable. Okay, and they're also finite. And the person's arm circumferences was 27.5 centimeters. So this is the that should be continuous. Okay, so they told you what here. So all the measurements are continuous. Now, next example, the quantitative examples about quantitative or qualitative. So, did you vote in the last presidential election? We expect only two answers, right? Yes or no. Two outcomes, yes or no. So this should be the qualitative. Okay. Now, what was the political party of the candidate you voted for? So the only, yeah, we had this, or so we have two political party, right? The Democratic or Republican. So this should be qualitative. How long did you wait to vote? So it should be maybe 20 hours, 20 minutes or 3 minutes, something like this should be quantitative. Okay. How far did you drive to vote? So maybe 2 miles, 3 miles. So it should be qualitative number, right? So what is your vote registration number? So it should be qualitative. So some digital number, ID, all these things belong to qualitative. Okay. So now sampling method. Okay, we have so far we have learned the example of bad sampling and the type of see a second, so type of the data. Okay, and then now learn the sampling method. Okay, so first one, we can normally the one of the best way to collect the sample data is to select the randomly. Okay, select the data randomly. Okay, so the each member of the population for the random, this each member of population has an equal chance of being selected. Yes. So example, use a computer to generate random telephone numbers. Yeah. And the systematic is this: select every k element in the population. So every fifth or every third item or a person. Okay. So this called that's the method is called the systematic. Okay. The example is selected every fifth person having chapel, leaving chapel. Okay. And the convenience is easy to get. It means that we just yeah just choose people in the classroom or school or office. Okay. So this convenience, um, see the convenience. What when you get the when you collect the sample data using the method convenience method, that sample easily likely to be what bad sample. Okay, right? Keep in mind this. And the cluster, divide the population into group. Then randomly select the sum of those group and choose all members from those selected group. So it's hard to understand, right? Let me give example. So example is this. I mean, like let's see here, like picking a cluster of a graph from the a shelf in the grocery store. So what that means, first we're gonna grouping. Think about this school. Okay, divide NGO into classrooms. Okay, maybe there are 50 or 60 classroom right there. Okay, so we're gonna divide the students in our school by classroom. Okay, so it's kind of grouping, and then we're gonna select the one or more classroom randomly. Okay, and then we survey every single student in those classrooms. That's cluster, and then stratified. Stratified is really similar to cluster, but the only different thing is once we group the population, okay, and then we select the some of the groups randomly, and then again we select the what people in that selected group randomly. Okay, so this look at this: divide the population into groups, and then draw a sample from each group. That's what we did in the cluster, right? Like taking a liter from each the strata or layer of 7 layer nacho. So and then the example is divide the NG into classroom, randomly select the one or more people from each room. Okay, so that's a big difference. So stratified is what? First we divide the population into groups, and then we're gonna select the one or some of them, not all of them for each group, but some of them for each group. Okay, keep in mind this. So example, the one sampling method for a study on women's shopping preferences, a questionnaire was mailed in to 1,000 women, and they were asked to please fill it out and return it. So see, Uh, the that must be what the random, right? So questionnaire was mailed to 1,000 women. So the they don't mention that, but they just select the mailing address randomly. Okay, so to collect the data for a water quality report, a researcher stretched a rope across the lake and collected water samples every 5 meters. See, every 5 meter, that's a systematic. And then in a study of the, treatments for back pain, subjects were randomly assigned for 4 different treatment groups by drawing their names out of a bowl. Give me a second. So this one, you see that randomly assigned. So this is random. Okay. Now next one. Uh, so to estimate the number of words defined in a dictionary, students randomly selected 20 different pages. And then just think about this. The students randomly selected 20 different pages. So for each pages has many, the word definitions, right? So we can consider that 20 different pages as 20 different groups, okay? So it means that the students randomly select 20 different groups and then counted all the defined word on each of those pages. That's the what cluster. And then next one, last one, in a survey about the current state of the economy, one business was selected from each page of yellow pages upon dictionary. So for each yellow pages, the 100,000 you know the what business contact information is on there, right? So for each yellow pages can be considered as a group. Okay, so these what so we choose randomly one big kind of business contact information for each page, yellow pages. That's the what stratified. Okay. And then now next one, collecting data, observational study, and then experiment. So now let me see. Now let's think about this. Okay, so um now let's see. Now we're gonna focus on the collecting data in science. Okay, so in a statistical collecting data is I mean statistical method are driven by the data that we collect. So we typically obtain data from two distinct sources. In a view of the science, so observational study and experiment. So, what's observational study? So, observing and measuring specific characteristics without attempting to modify. So, individuals being definitely studied. Okay, example is to sit, you know, at a stop sign on campus and observe whether students are using their seat belt. Okay, so what would So here that we wanna collect data whether or not people um the seat belt, then the the one way is to observe the drivers, okay, or passengers. Okay, so the next one is experiment. To apply some treatment and then observe its effect. So example is to show a crash video to half the students and then observe whether this group is using their seatbelt more than those who did not see the videos. Is experiment. Okay, so now the another example is ice cream and drawing. So example. So is there any correlation between ice cream and drawings? So observation study this. Observe the past data to conclude that ice cream causes drownings. Okay, so based on data showing uh, that increases in ice cream sales are associated with the increase in drownings and like this. And then Here the mistake is to miss the lurking variables of temperatures and the failure to see that as the temperatures increases, ice cream sales increase and drownings increase because more people swim. Well, here, okay, experiment this. They conduct the experiment with one group treated with ice cream while another group gets no ice cream. So we will see that the rate of drowning victims is about the same in both groups. So ice cream consumption has no effect on drownings. So here, the experiment is clearly better than the observation study, right? The example. So that example it should be in the textbook. So the please the read the all most of the examples in the textbook that will help you to understand. So now the experiment, what type of experiment the is there? The first one, the placebo effect. Yeah, we see that, right? So you made the here that placebo effect, that terminology in the news, uh, the about the COVID-19 vaccine, right? So when an what's the placebo effect? When an untreated subject report an improvement in symptoms. So example, nurses who ran out of morphine during the Second World War gave injured soldiers a shot of water, but told them it was morphine. So it's relieved their pain because their body made the natural endorphins that inhibit the transmissions of pain signals. So it also work for anxiety, ear infections, and so on. That's a philosophy effect. And then blinding is this: when the subject doesn't know whether he is receiving a treatment or placebo. So double blind is this: when the researcher doesn't know either. Okay. So example is, does sugar cause hyperactivity in children? So give half group of children a beverage sweetened with sugar and half without sugar. So those and they observe their behavior. And don't tell children or the observer who got the sugar. So blinding minimizes or accounts for the placebo effect, right? So now the confounding. So when investigators are not what distinguished among the effect of different factors. So example, a study about smoking and lung cancer among West Virginia coal miner. What caused the lung cancer? Smoking or coal dust? Coal dust. Okay. That's the confounding. And then block design. Groups that are similar but differ in ways that might affect the outcome of the experiment. Example, the the aspirin reduced the heart attacks in men but not in women. Okay. So and then the last one is the not last one, the fifth one, the match pair. So before, after, or twin married couple. So when you experiment the match pair, which married pair means the married couples or twins or same person before or after. A study of whether the fluoride prevented tooth decay was conducted with identical twins, where one child got fluoride toothpaste and then the other got plain toothpaste. Okay. Okay. So now next one is a significant statistical significance. That's the quite important. So look at this. Uh, mm, okay. Uh, okay. So we see statistical insignificance is achieved in a study if the likelihood of event occurring by chance is 50% or less. So here's the example. So getting 98 girls in 100 random birth is statistically significant because such an extreme outcome, that kind of extreme outcome is not likely to result from random chance. Okay. And then getting 52 girls in 100 births is not statistically significant because the event could easily occur with a random chance. Okay, so we can get this some result, and then in common sense, that outcome or that result uh, could not easily occur. That's going to be statistical significant. Okay, so see, when we get a result in a study that is very unlikely to occur by chance, that's the statistical significance. Okay, so now the other one is not here, is the practical significance. So you see that terminology in textbook. So practical significance is, it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of difference to justify its use or to be practical. Okay, so uh, the example is this. Think about this. In a test of a certain weight loss program, so 40 subjects had a mean weight loss of 4.6 pounds after 1 year. As an example, then using former method of statistical analysis, we can conclude that the diet appeared to be effective. However, however, although 4.6 pound is statistically significant, okay, using common sense, it does not seem very worthwhile because the without using that program, the people can easily the uh, get weight loss 4.6 pound without using that load program. So that is called the practical significance. Okay. So now the now next one. So the practical before going further. So let me uh, explain about practical significance more. Okay. So it is possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of difference to justify its use or to be practical. Just keep in mind this. All right. So now the errors. So mm, non-sampling errors. So actually, the the error, what does that mean, error? So when you collect the data or copy a data, you may get just by mistake, you may copy just wrong, just copy the wrong number, okay? Or just non-sampling error is, that's one example, non-sampling error. Error in collecting, recording, or analyzing data. So it's totally your fault, your fault. So for example, you make an error in reading a blood pressure cuff, okay? So this is non-sampling. Sampling error is discrepancy between a sampled result and the true population result due to chance. It's not your fault. So in inferential statistics, we will analyze and account for sampling error. Example: when newscaster report results from political polls, they show a plus minus margin of error at the bottom of the screen, which tells you how far off the sample result might be from the population result. Okay, so we're gonna talk about the sampling error later in detail. Okay, and then the last one is descriptive statistic. So far we're talking about the inferencer, the statistics. Okay, the uh, the sampling, about the sampling type of data, and then bad sampling, and then sampling method in an inference statistic, and then this one is about descriptive statistic center, uh, the variation distribution, and the outlier and time. So we're gonna figure out, the center is what the a value that indicate the middle of the data. Okay, and the variation is a value that indicate how spread out the data values. The variation is related to standard deviation or variance. The distribution, the nature of shape of arrangement of data. So the outlier is the data which is really far away from the center or the middle. Okay, and then the time is any change in the characteristic of data over time. Okay, so all data may be no good. Okay, so now, so we're gonna talk about this one in detail in later chapter, the two. Okay, so this is all about the chapter one. So the I summarize the all the class material in chapter one in this lecture note. So the please read the textbook, especially examples, to better understand. Okay, any questions? Let me know. Let me stop here.